Right. For statistics, and we have Tina,
Patricia,
Spencer.
and we're waiting for Sterling. Hopefully he'll join us shortly. So first we can go over lesson 4, the preparation. Did you guys have any questions on part 2 of that?
No, I didn't really. It was pretty easy. It wasn't horrible. So.
yeah, I thought it was going to be harder than last week, but it seemed to be pretty easy. I haven't done my homework yet, though.
Yeah,
so
I haven't got to that. Since it's not due yet, it's not done yet. That's where I'm.
Oh, you're my girl.
Someday I'll be ahead, but it's not today. So, all right, I will share my screen. We'll pull up the quiz, and we'll just start working through it.
Okay.
Google lesson 4 group meeting. Share. All right. Let me grab my scratch paper here. Okay. Oh yeah, 1 and 2 we each can answer ourselves, because if we did our individual assignment. And we're in the group meeting, so that's good.
Okay. So human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Okay, let me see. So the blood types and the proportions given in the table above define a probability distribution, true or false.
Let me look up my definition, make sure I'm.
Yes. So the blood type and the proportions given in the table above define the probability distribution.
I'm going to add it up and make sure it adds to 1.
Okay, probabilities follow patterns called probability distributions. There are 3 rules that a probability distribution must follow.
It equals 1.
Let me see. 45, 40, 11, 0, 4.
Yeah, I think I agree. I think
1, yes.
it does equal up to 1.
Okay, so it keeps rule number 1 at least. Right.
And it does number rule 2 is the sum, which is.
It cannot be larger than 1. It's not negative.
Right.
So that's 1 and 2. Yeah.
That's true.
That is true.
Yep, I agree.
Okay.
Okay.
What is the probability that a randomly selected person in the United States has type O blood? Round 2 decimal places.
So type O, the proportion is 0.45. And it's asking the probability.
This was all very clear yesterday when I did my homework, or the day before.
I know.
It's a little muddled in my head right now, so let me. So if it's the probability is of the event is P.
We need to put O, so the probability of O over 4.
That's right, minus the 1, right?
No, not -1.
It's just
Just over
1,
the 4.
1 over 4.
Yeah, I don't think it's minus the 1. It's just over the 4, so it's 0.11 is your answer. 0.45 over.
I see what you're saying. Over how many? So it's kind of
Correct.
Like 0.25, that's what you mean?
0.11,
so 0.11.
I believe. If you guys think something different, let me know.
I think you're right. It's like I said, I did the homework a couple days ago, and I should have refreshed my memory before I got here.
That's what I was kind of going over it a few times, and I was like, I don't know.
I don't remember. No, but I think that's right, because I think for probability, you take the proportion,
Yes. And
divide by the number.
by 4? Or by what?
Yeah, by the total amount of.
Mm-hmm. Yeah, the 4 different types of blood. Okay.
But isn't there one that you had to subtract and do by 1 less? Am I thinking of last week?
No, it is what you are.
I think it's the next question, actually.
Yes. That is when will not occur. When it doesn't occur. When type O is not. You know that when it's negative?
I think number 5 is where it goes negative.
Okay, yes. Okay.
Minus it out.
Mm-hmm.
Okay. I think I'm looking at it again. I think it's
So it's 1 minus P X. Okay. So it is.
It wasn't negative. I was thinking of it's just subtracting by 1.
Yes.
So
Like subtracting from 1, not like.
right, but
Yeah, that's rule number 3, right?
Yeah.
The probability an event will not occur. So in this case, will not.
it's 1 minus 0.11.
Is that it?
I'm trying to think. I'm not positive.
Hold on, let me see the examples. Oh my gosh. I think it's late. That's why my mind is not thinking.
My brain's not working either. I'm like,
Yeah. And I did this early this evening.
Calculate because if we're rolling the dice, the probability, like if we go back to the part 2 and we're talking about the probability of rolling the dice, you have a probability of rolling a 5.
I think you were right a minute ago. I think it's 1 minus the 0.11, which is 0.89 on number 5.
Let
Okay.
me see. Minus 0.1.
Now,
so it's 0.89.
0.89, yeah.
Of course. So that makes a total of 1. Yes, we have to subtract. Right. Okay.
Does that sound right? I'm still kind of.
Yes.
Yeah, vaguely. My only question is when we're looking at the dice problem.
Yes.
The probability of rolling a dice is 1 out of 8 for each number. So it makes me wonder.
1 out of 6, you mean?
My dice had 8 sides. But it's fine. Whichever. So it's 1 out of 6 or 1 out of 8. So does that mean what they're asking for? No, because they're asking for the proportions. The blood type and the proportions given above define a probability distribution. So I just didn't know if what they're asking for and what is the probability that a randomly selected person in the United States has type O blood? So it's not 1 out of 4 because as we discussed, it's got a higher percentage. Do you know what I'm saying?
Yeah.
Maybe. Am I way off?
No, it makes sense.
So
I think it's just that 0.89 is what it's saying is that's the probability of it being one of the other.
Right.
Exactly. Yes.
Okay. Let's go to the next one. If we turn it in and it's wrong, we have another chance to figure it out. So it might be kind of fun anyway.
Okay.
The dogs guess at random. What is the probability that they will correctly identify the dish containing the bladder?
Random order.
So random. Wouldn't it be how many bowls? 7? Isn't it just 1 divided by 7? Which is 0.142, 1.143.
Yeah.
Does that not make sense?
Yep.
What about to you, Patricia?
I'm trying to order everything in my head.
Okay.
So one of them was a cancer patient.
And they're just saying they have the 7 random bowls. And what's the probability that they will correctly identify the dish? So if there's 7 bowls.
Yes.
It's 1 in 7 chance that they're going to get it right.
Mm-hmm.
So you take 1 divided by 7.
Okay.
I get 0.143 with it being rounded. If that sounds.
Yes. Okay.
That sounds right to me. I mean, that's what I was thinking because it's just you explained it right.
So, yes. Mm-hmm.
Okay.
1 out of the 7. Okay. Good.
So then in a combined total of 54 trials, total, the dogs correctly identified the specimen of from the cancer patients 22 times. It is very unlikely that a dog would do this well with random chance alone. Which of the following statements is most appropriate? It provides strong evidence that the dog can detect it, or it's little evidence.
I'll say there's little evidence that dogs can detect bladder cancer. I don't think there's enough.
Well, they guessed 22 out of the
4. That's less than half.
Yeah.
The 40. Yes.
Isn't there some kind of a number? I can't even remember what the number is. Isn't it as long as it's less than 1 or something? What was the? I don't remember now.
Well, that's for the rules, right?
I thought there was a rule that if it went up to a certain amount, then it was strong.
Up to 100. But I don't know if that has anything to do with this.
I don't really remember that part. I'm trying to think of it, trying to look it up, see what.
Yeah, let me see if I can pull it up and I'll look. It's vague, and I can't remember again if it's this week or last week or.
Yeah.
Maybe a different class. I don't know.
Oh my goodness.
I thought there was something that said, like if it.
Yeah, the probability cannot be larger than 1.
Are you talking about that part that was the discrete variable mean?
Maybe.
Random variable or something like that?
Yeah, value could be listed. Maybe. What was that, Patricia? Did you remember it?
No, I'm not sure what you're talking about, but it says here that the probability of an event cannot be larger than 1.
Right, but I thought there was something about it being being strong evidence or little evidence. So let me pull up the book and do a quick search to see if it.
Because the dogs even guess half of it.
Yeah, little. Now they don't have strong or little in this chapter. So, but if the normally if there was nothing in there and they just randomly get it, that's 1 in 7, which is 0.143, and they actually got it 0.4 sometimes. So that makes me think that there's pretty strong evidence that they can detect the bladder cancer. Because randomly they were only going to get 0.14. And in this trial, they got 0.4. So that's 40% versus 14%.
Yep.
I get what you mean on that one. I mean, that.
Yes.
That sounds
Yeah.
right.
Strong. I guess we can always try and then change our answer, right?
No, it's
Okay. Sounds good.
that'll work for me. That was a tough one. I can't remember what it says.
Yeah, and I just looked and did a search and find, and nothing came up. So that makes me think that whatever I'm remembering is not from this chapter, at least. All right, number 8. The following M&Ms. Do you really have to tell us what M&Ms are?
Yeah, I know.
M&Ms are candies. The M&M website previously indicated in the United States the distribution of colors in a bag of plain M&Ms is given. M&Ms, what's the probability of getting a red? So we decided that's 0.13 divided by 6.
Yeah.
And so they want it to 2 decimals.
0.022.
0, yeah, 2. Okay, what is the probability that random selected green? Well, that's easy. Just take 1 minus 0.13 minus 0.14 minus 3 minus 0.24 minus 0.20. 0.16? That's what everybody else got?
I'm double checking right now. Yep.
Minus.
And then we divide that by 6, correct?
Do we have to? No.
Not the 0.16. That would be.
That's not your probability, though. That's just the. It says, what is the probability that randomly selected candy is green?
Oh, that's my proportion.
Yeah, proportion would be that amount, and then you've got to figure out the probability, which would be dividing it by 6.
So we just sum.
So 0.027.
Yeah. 2 decimal places. So it's 0.03.
Okay.
¿Qué quieres, Ariane? Ir a dormir, por favor. Por favor, ir a dormiros.
We all get that one?
Sorry, my girls are talking to me.
So for the probability of the not green, it's everything else, right?
So.
Yeah, everything else added together.
But that doesn't.
Sorry.
No,
So
I'm not sure on that one. I'm confusing myself.
all the numbers that we have and divide it by 6, right?
That's what we did.
Hold on. Divided by 6. So it's 0.13? No.
Are you on number 9, Patricia?
Yes. I'm trying to figure out if I understand everything.
Yeah, but it says, what is the probability the randomly selected candy is green? I actually still think it's...
It's just
You know the 0.16?
Yeah. Because the probability of rolling a dice number is 1 in 8 or 1 in 6.
Yes.
Oh, so hold on a second. So the
I think
proportion.
correct. Those are proportions of what it is. So to figure out the probability, you have to take it by 6. Because it gives you we had to figure out the proportion. That's what we did by taking all the numbers. When we
Right.
the probability has got to be by 6. You've got to divide it by something to get a probability.
Oops.
As far as it may, I mean, that's what I.
Yeah. They're rounding it to 2.
You said the question before. Yeah, what is the probability?
So the probability if we divide it by 6 is 0.03. But then to do the other one, do we add up?
It has to get to 1. So then after that number, okay, so it will be 1 minus all these numbers.
Right.
That will give us the proportion. And then we'll divide the proportion by 6. Am I right?
Yeah, that's what I got. Yes. And I got 0.14.
That's what you got? Okay, hold on.
For
There's
10.
one.
So it's technically you're putting each one over 6.
Right.
And then subtracting it from 1.
And that makes sense because I wrote that all out. I mean, in the discrete random variable stuff.
Yeah. So that's what I was because I was trying to think of it. I'm like, you got to put them all over 6, and then.
But that's to find the sample mean.
Oh my gosh.
Finding the mean of a discrete random variable is when you put it over. Probability of 1. I was just going to run through the.
Yeah, it has to be divided by 6, I guess.
To find out that it's for the not green, we're on number 10, right? Or are we on number 9?
Number 10.
Okay.
I got 0.14.
Hold on.
I'm trying to figure. I think it's 0.87. Not positive, but.
I thought we had to divide it by 6.
So you have to divide each one by 6 first. So the 0.13 by 6, the 0.14 over 6, the 0.13 over 6, 0.24 divided by 6, and 0.20 over 6. And then subtract all of those from 1. So you have to get the answer for each one of those.
Mm-hmm.
Yes. Yeah, but that's doing the same thing as sum in all numbers and then divided them by 6.
Point.
Right?
I'm trying to,
we should get the same result.
But we don't.
Oh, no?
No, it's getting a different answer that way. That's what I was trying to. Because you get 0.02, 0.02, 0.02, 0.04, and 0.03.
Mm-hmm.
And all of those then get subtracted by 1. So 1 minus 13 over 6. Or sorry, 0.1. Never mind. Now I'm confusing myself. I'm getting lost now. I'm like,
I think they should give the same result. Because it has to give the same result, because when you go down in the textbook or whatever, the readings, it's just the same example. You sum everything and divide it by 6,000, for example. Do you see it?
But I thought that was finding the mean.
Yeah, I don't think we're finding the mean. We're finding, because you have to find each probability first. Those are just proportions again. So in this one, it's just a proportion on each one of them. We've got to subtract. You got to find out the probabilities of each one, and then subtract the probabilities, not the proportions.
Yeah, but when you go to 2.2, the probability is still division, you know? Is when you divide 1 by 6.
Probability.
But that sample mean that you are talking about is when you have 2 columns with different results. I think we're getting messed up, but we're doing it right.
So, Patricia, what do you think number 10 is? The probability that a random selected candy is not green. What did you get for your answer?
I think, hold on, I'm still in question number 9.
Okay. What did you get for question number 9?
0.16.
And I got 0.03. So you did it by taking what the number you figured out, 0.16, that's the proportion. I think that's what Spencer was saying. That's the proportion. The proportion of 1, so all the proportions equal 1. So if you take the 1 and you minus all of those numbers, you get the 0.16 like you said. And then what Spencer said is you take that 0.16 and divide it by 6.
Yeah, I already divided it by 6. But when you go to the 3 rules, you know, you're doing just the same thing. Probability, for example, probability notation, you're still dividing it.
Right.
And it has nothing to do with proportion. I think we're getting confused between proportion and probability.
I'm thinking we did actually I'm looking back because I was thinking as we were doing this one too. I think we did number 5 wrong. Because if we're doing it the same way that we've got to put the probability and not proportions over it, then we have to do the same thing on 5 as we're doing on 10.
No, I think proportion and probability is just the same thing.
They're well, because the proportion is having like 6 M&Ms. The probability is how many times out of that you're going to pull one of those colors out. So proportion is different than what a probability of, because the proportion is not going to be how many times you pull that same color out. It's just going to be the amount that's in the bag. The proportion to the rest of them. So there's so many of that color compared to the rest of them versus the probability of how many you're going to pull out.
So then for question 5, so then did we do 4 wrong too?
Yeah,
I might be wrong. I'm not.
Well, and that's I was trying to look through the reading.
Mm-hmm.
But it shows the rules of probability, the probability of the event, if you list the outcomes, but I don't see where it's talking about proportions.
It doesn't talk about proportion anywhere.
So you're saying proportion and probability are the exact same thing then?
That's what I think.
So on 5 and stuff, those are like the blood types, that 0.45 is the probability of it?
So the proportion, I think like Spence said, it's here under 3.1. The question under 3.1, 16, what proportion of the time do you think you would roll a 1? Since all the equal numbers are equally alike, 1 out of 6.
I think now that I look at it, I think I'm looking at it harder than it really should be.
Yes, I know.
I think
I'm completely.
Proportions and probability are the same thing.
That's what I think.
So
M&Ms would be in like whole numbers. They wouldn't be in decimals if they were actual like proportions.
Right.
They're already in decimals. They're already been put in the probability of it.
So you think we have 4 and 5 right, but then when we get down to, let me find it.
Yeah, if you go to in our notes 3.1.
3.1.
Yeah,
okay.
Question number 16.
Yeah.
Look, what proportion of the time do you think? So what we are actually finding out is the probability. So the proportion of times that each digit would occur is 1/6.
And then you do the decimal.
Exactly. I think proportion and probability are the same thing.
So question 8 then would just be 0.13, because I'm guessing that it's already figured as a proportion, so it'd just be 0.13.
Right, because that's the remaining from 1.
Correct.
I agree.
That's all they just gave you, because they just gave you that already. The probability of it is if we're saying that's what it is, then it's just the 0.13.
So what's the probability of rounding selected? The candy is green.
So it will be whatever is left to make.
Which isn't that 0.16?
Yeah, it's 0.16.
0.16, right?
Yes.
Okay. Sorry, guys, I made that harder than that should have been.
That's okay.
No,
I
think we need to think about it.
I don't know if it's better or worse that we're all in the same boat.
Yeah, my thoughts are like spinning around my brain, and everything is unclear.
That's all right. We're good. Number 10. So then what's the probability that a randomly selected candy is not green?
So it would be the sum of the rest of them.
Would that be 1 minus 16, so 0.84?
Exactly.
Yep.
Okay. Wow. That was more difficult than I should have let it. I'm sorry that I couldn't even be like guiding in there. I'm like, I don't know.
Well, that was my fault. I kind of made it a little more confusing. I was going harder than it should have been.
I think like into the defining the mean, which is a bunch of adding and subtracting and all of that, which is probably what this next one is.
Yes.
The ACT scores of students admitted to a medium-sized public university in the Western United States were taken from the kpex.com. The following statistics were calculated. Half of the observations are less than equal to what number? Well, that would be
reviews,
right? So 24. Right?
The median. Yes.
Okay.
Half of it. Yes. No.
The information on the table, the top 25% of students scored above what number? 27? Right?
Q3.
The top 25%, isn't that Q3?
That's for last week's lesson, right?
Yeah.
I'm trying to understand that part. Okay.
But I think because the top 25 is going to be 27 and higher, with the maximum being a 35.
Is it a Q? Is it a Q1 or a Q3? Because I'm trying to remember if it.
Top. It's the top 25%. So
okay.
3.
Yeah. Okay.
Because Q1 would be the lowest 25%.
Mm-hmm.
Does that make sense, Spencer?
Yeah.
Okay.
That does.
Yeah, I have to write down that little box where it said that thing.
All right. Which of the following statements is not one of the 3 rules of probability?
That's going to be easy.
It's number C. If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. You can't have a negative probability.
Exactly. That's rule number 1, right?
Right. Okay. I'll go ahead and submit mine. Cross fingers. Submit. And survey says we missed number 4, 5, 4 and 5.
4 and 5. Let's see what.
Number 4, what is the probability that a randomly selected person in the United States has O blood?
Did we not go back and fix that one? I thought we did.
Yeah.
Oh, no.
It needs to be 0.45. We didn't go back. We had calculated like before.
So,
okay.
Hold on.
So, yeah, the probability of a person with the O is 0.45. Probability will not have that is the 1 minus 0.45.
Which is
5.
5. Yeah. See, we made it so complicated, and it was not that complicated.
So, okay, somebody else go ahead and make sure that those are right, so that.
Yeah.
Okay, I'll do it.
Yeah. And now my brain is fried because giving too much thought into it, and it's not that.
Right, and I still need to read my business law class tonight.
Yeah, I have to do that business case, and I'm like.
Yeah.
Okay, I'm submitting. Hold on 1 second.
Go for it.
These girls are not going to bed.
I think mine finally gave up.
Okay, perfect. 100%. That's it.
Thank you, guys.
Thank you. Sorry.
Thank you.
Thursday, same time?
That'll work for me.
Yes.
Okay. All right. I will
Thank you.
invite everybody on Thursday then.
Sounds good.
Thanks.
Okay, thank you so much.
Are you posting this on the page, Christina?
Yeah, I'll go ahead and do that.
Okay, and then you saw that
Okay.
we each have our name on there, right?
Yes.
Like when you post it, it's got to be like each group person's name, correct? Yeah. Okay.
Okay, thank you, Christina.